Hi there. In this lesson, we're going to look at a couple of different types of web security: connection and content. Websites use Hypertext Transfer Protocol, or HTTP, to send and receive packets of data or information. The data is transferred to and from the client, or user's computer, and a server where the website's data is stored or hosted. To encrypt and protect that data while it's transferred, most websites today use Hypertext Transfer Protocol Secure, or HTTPS. This encryption relies on adding a secure sockets layer, SSL, or more recently, a transport layer security, or otherwise known as TLS. HTTP is not encrypted and is vulnerable to man-in-the-middle and eavesdropping attacks. Many web browsers today warn users of unencrypted websites, and some tools force users to only allow encrypted sites. Looking for the S at the end of an HTTP within the protocol portion of a site's URL address is a really good way to check for encryption. An unencrypted transfer of data can allow others to inject code, steal data in transit, or even modify the website. One common type of content security is known as cross-site scripting, or XSS. This happens when an input, form, string, evaluation, on-mouse click, or anything along those lines is used to inject code into the website. The code may be unsafe and malicious. It could execute a script designed to steal data or send malware. A website can try to prevent these attacks. As an example, let's take a look at this input field. A username is requested, a name is typed, the string is submitted with the OK button, and the website greets the user. Now let's see what happens when we insert some JavaScript into the text input field. This demonstration script will pop up an alert with a message indicating that the site has been hacked. The JavaScript was sent to the site as a string of information, inserted into the site's HTML, and then executed as a script. There are several ways to protect a website from cross-site scripting and code injection. One way is to escape specific symbols or characters. This basically creates an allow list or a don't allow list of characters for the text input. JavaScript can be used to escape characters, but let's use an HTML5 attribute in the input tag. The pattern attribute lets us specify which characters are allowed or which ones are not allowed. In this example, the up caret symbol tells the web browser to not allow any of the characters after it within the brackets. Let's include some characters that are used in JavaScript and HTML, like a semicolon and less than or greater than symbols. Then we'll add a plus sign after the last bracket to tell the browser that any other characters that are entered are allowed. Let's see what happens when the JavaScript code is now injected. Now when the JavaScript and HTML symbols are found within the text input, the browser no longer allows it to be submitted. This is one way of escaping characters and blocking cross-site scripting. Using a content security policy in a website's HTML head is another way to add an extra layer of protection and tell the client-side web browser what to allow and not allow. Each content security policy includes a list of policy directives that describe what's allowed for certain resources. For example, this content security policy is set to self, which tells the web browser to only allow content to come from the site's own origin. Instead of using the script tag to write inline JavaScript code in an HTML file, call on the script as a separate JavaScript file. Avoid using the evaluate method. It can be used to calculate strings, but also creates a security loophole. Strings should also never be executed as JavaScript. Instead of calling setTimeout or setInterval as strings, create a function for those. Now that you've explored a few website vulnerabilities, let's take a deeper look at securing a website.